Hey Eric, how you doing tonight?
I'm doing all right.
Well, that's good. I talked to somebody earlier today, and he was like, "You guys need music
Again?
again." No, dang it, no. I'm sure at some point in time it'll have to happen, and I will be thrilled at what it sounds like.
You'll come kicking and screaming?
Today is not that day.
Maybe that should just be the music is. All right.
How was your week?
For like the last 20 minutes I've been thinking, what am I going to talk about my last week? My week was very much heads down trying to pound out the last little bits of the iPhone app I've been working on.
Yeah, that you teased a couple weeks ago. So it's not a secret.
Nope. So Snip is in App Store review.
All right.
So hopefully by the show next week, it will be available for download.
How long do you expect it to sit in review?
So there's a website or a Twitter feed that checks App Store review times, and it looks like it's 3 to 5 days right now.
Okay. So there is a good possibility that I edit this podcast and release it before Apple completes.
I'm guessing it's probably going to go on the long end of that time range since this is the first time it's ever been released and they have to check all the collateral,
right?
The privacy policy and the marketing URLs and the support information, all the stuff they make you have now.
Right.
I think I'm a little nervous because some things I've seen said if you have certain things in your app, you need to have it localized in every language where the app goes. It has an in-app purchase. That's the one. But then I've seen plenty of other apps that have in-app purchases that don't localize in every language. So I don't know. We'll see.
All right, we'll see. Good luck.
Yeah.
Good luck. So that
was my week.
That means that I can actually use it to market this episode, though.
In theory.
In theory. I will have to try that out.
Well, you also have a beta version, so you could have done it last week, too.
Technically, I guess.
Or I could have done it last week.
I guess. I don't know. I'm thinking that because I normally choose the title from something that we say somewhere on here. So it seems like having, even a 5 seconds before and 5 seconds after of whatever the title is would be an interesting thing to post.
Yeah, that'd be fun. Well, we'll see. That was the whole point of building the app. Was I was like, how do you tweet out cool little audio clips of your podcast? And that was the genesis of the app. I looked at the calendar, and my very first build where I had something sort of functional was back in October of last year. So it's been a good 6 months.
Wow, 6 months.
Yep.
If you had asked me, I would have said December.
That's probably when I started picking up in earnest. Version 1 was in October, and by December it was version 99, and the release version is version 181, I think.
Is each one of those a build?
Almost. Each one of those is a build that I wanted to push to either test flight or the App Store somewhere.
Cool.
So early on, I had it doing every single build, and then I was kind of it's just a random number, so why bother? So I only did it when I pushed to the App Store for test flight. So
cool.
After probably 100 and some odd. Anyways.
Yeah.
No one cares. Moving on.
Yeah, that was maybe a little too... So
maybe cut that part out.
Well, now I can't.
There's your title right there. Maybe cut that part out.
So
follow up.
Yes. Well, I had one minor bit of follow up, which was I guess specifically for Peter, when you had Peter on the phone or on the episode that I was on vacation for at the end of February. His something fun was Libby, the app for libraries, and I found that to be intriguing. I hadn't heard about it, and I installed it, and I don't think my wife has read anything other than that for the last couple of weeks. So she's
Nice.
been getting books, and that's awesome. So go, Peter. Thank you.
Very cool.
Yeah, it was super easy to set up and just shockingly easy. So go check out Libby if you didn't hear that episode. That was really cool.
Awesome. My piece of follow-up is on the, how long has this been? End of last year, there was the Starwood hack.
Marriott.
The Marriott acquired Starwood, and then they found out that Starwood had lost the entire reservation database and passport numbers and large amounts of stuff. I guess they were testifying in Congress, or the CEO of Marriott was testifying to Congress and revealed some additional information that was not known before. One of the way that it was even first discovered was in before they had merged the systems or were looking at merging the systems. One of the security tools used by Starwood at the time had noticed a specific type of query that was being run against their reservations database. And it was the type of query that you didn't automate. It was something that had to have been run by hand. They went and did some research, found the user's credentials who had run the query, and it was not that person who actually ran the query. So then they started digging in. They found what's called a RAT, a remote access Trojan, that allowed them backdoor access. And then they started bringing in the big guns to start doing some deep dives, and found that there was also Mimikatz was running, which is a pen testing tool that allows you to search for usernames and passwords. It's both used by good guys and bad guys alike. And it said they had spent months, I guess, searching for any evidence of data being extracted from their system to see if they really had a breach, or if kind of the evidence they had was just early and or hadn't done anything yet. And they got to the point where they even found that, oh no, this stuff has been here since 2014, but they still hadn't found anything until November 13th. And this is the quote I was going to read, because this was kind of the most interesting piece to me. Was on November 13th, our investigators discovered evidence that 2 compressed encrypted files had been deleted from a device that they were examining. The files were encrypted and the actual content was unknown. There was also evidence to suggest that those 2 files had potentially been removed from the Starwood network. 6 days later, on November 19th, 2018, investigators were able to decrypt the files, so it recovered the deleted files, decrypt the files, and found that one contained an export of the table of the Starwood guest reservation database containing all the guest data, while the other contained an export of a table holding the passport information. So that's when everything went south for them. Is they spent a lot of time digging in and doing their due diligence, and it was not till months later that they actually discovered that stuff had actually been removed from the network.
So sorry, the first alert was in September. Okay. Wow.
Yeah. And it'll be interesting to see how these things play out with things like GDPR, which kind of requires you to notify users of breach within a certain amount of days. And what constitutes a breach? Is it the November 19th date where they actually figured out what actually was removed? Or is it the September date when they noticed something not quite right was going on? So, I don't know. We'll see.
Yeah. Yeah, that's very, very interesting. I have to assume that it would be as soon as they know.
When you know for sure.
That, yeah, otherwise how do you know who to notify? Right. But okay, right. That's some great additional data. All right, well, jump straight into topics, or do you have another?
No, I got my topic. It's all about Project Zero.
Project Zero,
But
Google.
yeah, but not that Project Zero.
Oh, no,
We have a name collision.
that's not a unique key.
No.
Oh,
So, and I guess this one is not necessarily software security related, but Amazon has a problem with fake and counterfeit products, especially high-end, different types of one-off things.
yes, they do.
Handbags, whatever. I
Birkenstocks.
think Birkenstocks, even down to Apple AirPods.
Oh,
I saw one article I read talked about how a journalist who was researching this was actually able to buy AirPods off Amazon, which were fake. And Apple, of course, has been trying to get Amazon to remove counterfeit stuff. Everybody is, right? It's a big problem.
Yeah.
Amazon definitely has a problem. Well, they have launched, right now it's invite only, a Project Zero. The Amazon Project Zero.
as in zero counterfeit products on Amazon?
I suppose. But I think the interesting thing with the Project Zero, which I'm not sure how to deal with this one, is the tool that they're providing to these, like the original owners, is tools for the brands to actually remove the counterfeit listings themselves.
And how can that be possible without validation?
That's going to be an interesting piece of this to watch, because if they're going to allow brands to remove counterfeits, what if you just kind of quietly remove a competitor's stuff? Anyways, and then another piece that was interesting here is they're adding a product serialization service, so that when a product sends stuff to their warehouses, they can have a unique serial code attached to it and where it was manufactured. And then when that serialization stuff shows up at Amazon, they can scan the authenticity of the purchase. So a way to help try to detect that before it even reaches the consumer.
I'm confused. Sorry, explain that last bit, because I hadn't had a chance to read this article. So let's say I'm a manufacturer and you're a reseller, but you resell through Amazon. So as the manufacturer, I can give Amazon a bunch of serial numbers, and then if they match with what the reseller provides, then they're deemed legit. Sorry, or explain it. Sorry, maybe I missed.
No, that sounds about right to me. So the actual information in here is that product serialization is a service that allows us to individually scan and confirm the authenticity of every one of a brand's products that are purchased in Amazon stores.
Okay. All right. We're out of security. So awesome to reduce the number of counterfeit goods on Amazon.
Right.
Yeah. Okay.
Yep.
All right. Well, hey, that's cool. I don't really want to add up. I probably should maybe add up how much we spend on Amazon. I should do that. I'm not sure I want to know though.
Yeah.
I feel bad.
All right.
Okay.
Your topics.
My topic. I have two. Sorry, man. But I only have one something fun, and I see you have two. So
that's right. Payback.
Quid pro quo.
Karma.
So my first one is the fact that this past patch Tuesday, Microsoft released a patch for Windows 7 that adds SHA-2 support to its binary signatures. So
are we up to Windows 10?
We are up to
Windows 7
10.
old?
Windows 7 is more than 10 years old, yes. Yes, it is. I'm assuming you don't have any Windows 7 VMs anymore?
No.
No,
No, of course I don't.
I, oh, I see. You actually put in the notes. Of course not. I actually do have a Windows 7 VM that I occasionally boot up. Although every time I do these days, it's been a couple months, and then I have to run a bunch of security updates. But yeah, so this is. I'm sure that Microsoft is doing this kicking and screaming, so to speak, which because they don't want to support Windows 7, but they also don't want to continue to have the binary updates signed with SHA-1 because of it's been demonstrated to be vulnerable, but Windows 7 doesn't support SHA-256 signatures. So for the last, I don't quite know how long, all of their updates have been signed with both SHA-1 and SHA-256. And, which is kind of tricky in that you have to make sure that the older software, only sees the first signature and can validate that with the SHA-1 for Windows 7. But they want to not be using that, and I don't know if the impetus here is because they're starting to see active use in the field. I haven't actually heard of anything specific there. The SHA-1 vulnerabilities that I've seen are still mostly, and maybe there's something else, and maybe I should cut this out, but I think it's theoretical, but it's real that it could happen. But anyway, so they're stuck. So they have to basically release a patch, or they released a patch for Windows 7 that adds the ability to verify with SHA-256, and that means that they and they are going to stop signing with SHA-1 in July. So after July, if you don't install the patch today, you will no longer get updates, because the Windows that you're running won't be able to verify them, so it won't apply them after July.
Well, how much longer is Windows 7 going to even be around? Shouldn't it? Like I said, we're up to Windows 10.
Hi, Windows XP. So Windows 7 is already in extended support, so it's not supported normally, but the extended support actually ends. I actually pulled that out of a different article because I wondered what the market share for Windows 7 was and why they were doing that, but I found an article from The Verge that describes Windows 10 as having overtaken Windows 7 only, at the end of last year. So as of December, I guess the article was 1st of January this year, the Windows 7 market share was still 37%. So that's still significant. And extended support ends less than a year from now, on January 14th, 2020. And just in case you weren't aware, it is already 2019, which kind of freaks me out sometimes. I just had a moment. It is 2019, right? Oh, that's so bad. But yeah, so the presumably there's a reference in this article to corporations that might continue to pay for I forget what they called it, but super extended support. I assume I don't know what Microsoft does, but for any long term support on software, I think there should be like an exponential scale. Yeah, we'll support you for after 5 years, it's double the support cost. After 6 years, it's, times
Double
2 again.
Yeah.
just do a power of 2 every couple of years, and like, oh yeah, you want us to support 20-year-old software? We will totally do that, because we have a guy named John who is totally happy to support software that was written in 1995 if you pay him $10 million a day or whatever.
Yeah.
Anyway, so what else was I going to say about? The other thing I was going to say about this was one of the thing that I'm assuming I parsed this right, but when I first read it, I was really confused, because they're going to re-release this same patch in April as a security patch, and it's the as a security patch that I think was the critical distinction there. Is they're releasing it now as just a regular patch, but they're presuming, or I'm presuming that they're presuming, that some people might not update it, and so they'll re-release the exact same code as a quote-unquote security update in April, and hopefully catch a few more people that might have just ignored it beforehand, or because after July, updates will not work unless you
Auto updating is the way to go.
Yeah, totally. I'm very much in that camp. So anyway, I thought this was interesting, just in the fact that A, it's still around, and B, Microsoft's kind of been forced, their hand's been forced to add support to a newer protocol, to a legacy OS, and they've had to do that for XP a couple of times too,
Right.
over the years. Okay, my second topic. So this was a serverless topic on dark reading, but it was the top 12 serverless security risks. And I don't think we've talked much about serverless on this podcast.
No, which is surprising. When I saw this, I'm like, this is one of your hot buttons.
It is.
This is one of your favorite topics.
It is. It's something that I like a lot, and I've been, kind of a proponent of for years. But and to be honest, I think one of our first 5 episodes that we didn't release was all about serverless. Yeah. But those episodes shall not be named. But I feel like I'm not sure who's listening to this, if they know what serverless is. So I'm going to give like a brief over. I don't want to go too long, because I could probably talk about it quite a while. But the serverless architecture, let's say, is when you can deploy logic, your business logic, to respond to this can be, responding to events, like you can even do it on AWS and on Azure and on Google as responses to events like HTTP methods. So you can basically have a web server that responds to events, or you can have logic that responds to events that happen in other back-end systems, like something being posted to a message queue. But essentially, you write your application logic in a function, and the function takes inputs of whatever the event was, and it affects other systems, but you don't control any of the infrastructure on which that function runs. You just say, when this thing happens, I want you to run this function. And the really important thing about this from an application architecture standpoint is serverless architecture can scale amazingly well, because the infrastructure provider is the one that has to be able to execute the functions on in response to the initial events, but they can do that on, as far as the application author is concerned, an infinite number of devices, and they can share them between tenants in the cloud service seamlessly. So, it might be that your execution environment, in fact, most of the execution environments that I'm aware of, actually do use something like containers in which to run functions, and they'll spin up a container and run your function inside that container somewhere. But essentially, as an application author, you don't even think about it. You can run 1,000 concurrent functions at the same time. They might be running on 1,000 systems. They might be, running on 500 systems. They might be running on 2 systems. You don't know. It is absolutely true that there are servers in serverless, but as an application author, I just don't have to worry about them.
Right.
In general. And there are, if you get down into the weeds, you can worry about things like cold start time. So, what happens when a function hasn't been called for a while and the infrastructure provider has to spin up an environment to execute it in. Your first execution might take a particular amount of time, and there might be some latencies for scaling out, that kind of thing. But just in general, a lot of the worries that you have when you're building an application, and you worry about what happens if, my normal application load is 10 requests a second, and then all of a sudden I get, 10,000 requests per second. What happens? Well, in the serverless world, it just works. You do have to worry about things like running out of money because, what happens if it then scales up? But you can put limits in terms of, concurrent. I only want this to be able to execute, 1,000 at the same time. And so, you can put some controls in there to throttle it. But, in general, it's just a very nice, clean scaling model. And then, my final point in kind of favor of serverless that I love is that it's kind of the ultimate reflection of you're paying for infrastructure to run something when you have something to be done. So, it might cost you, 1,000th of a penny to respond to a request, but you're actually getting that request. And so you're not paying for a server that's, always running 99% idle, in order to respond to whatever the minimal number of requests are. You know very much that you're going to only have to pay for compute when there's some compute to be done. So it's it especially in the early stages of a startup, for example, or an experiment. It's very nice to be able to say, hey, I just want to pay when, for the work I'm actually doing, not for the ability to do more work overall. Anyway, blah blah blah. That's a little bit about serverless. But so what I thought I'd do is this article has the top 12 security risks with serverless, but I thought I'd pick out my top 3 because otherwise it would take a long time.
So your top 3 in terms of that you think are the most
these
important security risks, or just interesting to you, or not as big a security risk as they are? What is your angle on?
What's the metric? What's the unit? I think important. So
okay,
important, and even that, I guess you could think has a couple of dimensions, or maybe the most important that you get right, or the most risky if you get it wrong. But
got it.
But that's and maybe also the most common to get wrong in at least the second one here. So my first one is their number 1, and I don't think these were in any particular order. I couldn't tell a order. If it said that it was an order, I must have missed it. But the first is that they call it function event data injection, and basically this is server side validation. At least this is the way I would think about it, because you have to do server side validation in any client server application, because you should always assume that a client that is sending you data is malicious and trying to crash you and steal your data and do anything, in its power. So clients are always malicious from the server's perspective. So you need to check your input. You have to make sure that there's data is properly escaped, that you're not taking user supplied data and turning around and allowing that user supplied data to be executed in other parts of the stack. So, this is how you get SQL injection vulnerabilities. This is how you get cross-site scripting vulnerabilities. This, proper escaping of user provided data is it's not unique to serverless, but it's the most important, one of the most important things that you need to do.
This is the little Bobby Tables meme.
Yes, of course. That's a XKCD about. Now we have to put a link into that. It's got to be one of my favorite my favorite XKCDs, or my favorite cartoons of all time. So that's certainly I would agree with as a number one. The second one, my second one, is actually what they said risk for in this article, which is overprivileged function permissions and roles. And I know you agree with me about this, because how many times have you complained to me about IAM?
What's today?
Yeah, exactly. IAM is Identity and Access Management. And at least in AWS, that is a specific service that they have. That's how you can set up roles and permissions in AWS for who can do what to which. And IAM policies are nigh inscrutable. And And I can tell you straight out, and if I said otherwise, I'd be lying to your face, that I have absolutely put a star next to permissions in AWS just so that I could get things to work, and then have to figure out, so what actual permissions do I really need? And so this says, it's quite common to see developers cut corners and apply a wildcard to a permission. Yes, and that's really bad in real production. No, yeah, exactly. when you're just doing an experiment, and the point is, hey, can I get something to work? Not, am I building this? And half the stuff that you and I would do isn't even really exposed to the world, but it's a hygiene thing, and it's absolutely a risk that. Permissions are not locked down to the minimum permissions required to accomplish something. And, you've said, oh, you can write to any S3 bucket or read from any S3 bucket. And now all of a sudden, if there's a vulnerability in the function, and the function has permissions that are beyond what it absolutely needs, then maybe somebody can use that function to exfiltrate data. If you can combine it with the first thing, where you can send it event data that, gives you some control, then, and you have permissions inside the function that you shouldn't have. Now all of a sudden, there's lots of things that you could do. So that's I would absolutely agree that would be my number two, at least.
I'm with you on that one.
Yeah.
Your number three.
Number three. My number three would be, they actually call it risk number 6, which is insecure third-party dependencies. So
talked about this before.
We have talked about this before. But this is, to be honest, none of these three are specific to serverless. None of these three are, right? I mean, which goes to the, new situation, same old problems, I guess.
Yeah.
But one of the amazing things about development today, at least at the top of the stack, if you're developing with Node or with Python or with C# or with Go, I mean, any of these new application development languages, it's not the language, it's the libraries and dependencies that you build on top of. And I'm sure we've talked to specifically about Node, I guess, about what happens when you stand up a new prototype or a new like even a tutorial for Node, and your npm init, and you just pull down 700 packages, and yes, oh my gosh, you can write so much functionality in 100 lines of code, and your 100 lines of code are the eye of the needle sitting on top of a mountain of 5, 10, 100,000 lines of library code. And where did that library code come from? And are there any vulnerabilities in it? And who's updating it? And are you taking the updates without validation? And what happened just a few weeks ago or a couple months ago, where you have libraries that are literally being sold so that they can be updated maliciously. Yep. So anyway, that would be my number 3 of on this list. And the others, I wouldn't disagree with the others, but these are the 3 that I pulled out and said, these would be my top 3. But there's that's a good reading, a good article to read. And
it sounds like your cat agrees with you too.
Yes, my cat has just showed up next to me. Yeah. All right. I think that's enough of that. We should probably need to move on to something fun.
All right, I have 2 something funs.
Okay, all right. Turnabout's fair play, man.
I can stretch these into 3 something funs. No, so
okay.
There was a... You know one of my favorite quotes.
I do.
But there was... The Entrepreneur magazine had an article that the title is... Scientists say they can recreate dinosaurs within the next 5 years. And that's something fun in and of itself.
That is cool.
But
yeah.
Even more fun, Jeff Goldblum, who played Ian Malcolm in Jurassic Park, had the opportunity to use his quote for real.
And did he really say it? Hold on.
He did. We'll link the tweet. He said, "Your scientists were so preoccupied with whether or not they could, they didn't stop to think if they should." Oh. As a reply to the magazine article's tweet. Isn't that awesome?
Oh, that's fantastic.
Anyway.
So who I got to just know who, somebody forwarded him and said, "Hey." That's
probably, yeah.
So
hey, go use this. Anyways, so that's my one something fun. My second something fun is a little bit more meaty. We'll call it. One of our data scientists from work, she's up in Ireland, and she has been pulling together a whole bunch of data about quantum computing and quantum computers. And she had posted a paper that I read, and I thought it was really, really cool because the title of the paper is Scientists Reverse Time with Quantum Computer in Breakthrough Study. Scientists have reversed time. I know. So here's the thing, though.
I don't think that means what you think it means.
Here's the analogy. Rather than try to go into the deep dive, because it's a full scientific paper, and I'm sure it will get peer reviewed, and other people will have to recreate the experiment that they did. But right, most laws of physics work whether it's in the future or the past, right? And the analogy they give is like you have a pool ball, and if you have a video of a ball going and bumping against another ball and the other ball moving away, you could run that video forward and backwards, and the physics of the physics of that action, you couldn't tell if the video was running in forward or reverse, right?
Okay.
But there is one of the rules that does only go one direction, right? The second law of thermodynamics, which is you have order and then you have chaos. And the analogy they give in the article is, think of a rack of pool balls. They get hit and they break apart. And so if you play that video backwards, you see that rack of balls coming together as one. It's obvious that it's now being played backwards. And so this is what scientists effectively did at a quantum level. And they talk about qubits and all sorts of other stuff that I won't bother trying to dig into. If you really want to go, I mean, the paper is rife with math. So go dig into the paper if you want to really get into the math of how it is. But I'm just going to say, hey, somebody has solved time travel.
Solved time travel. Oh gosh. All right. Well, I haven't read it. I'll have to find the actual study.
Yeah, it's linked inside the articles.
Okay.
The overview article.
Okay. All right. Well, I'm not going to read it. I'm not going to read it on the air, so that would be boring.
It's actually boring not on the air, if I'm totally honest.
That's funny. Okay, but that's cool. That's cool. That qualifies as a cool thing, not a uncool thing.
Thank you. Thank you.
Thank you. You're welcome. You get the John Cool Approval Award.
That's right.
Okay, my something cool is also sciencey, science-ish.
Yeah, that's new for you.
New that it's a science thing. Oh, well,
yours are always sciencey. That's always your something fun.
Oh, well. This is an article in Scientific American that says 4 new DNA letters double life's alphabet. So this is an article. So this was actually from a couple weeks ago. I think I read this while I was on vacation. But then when I came back, my something fun was about the vacation itself, and then I don't remember what it was last week. So I had to reach back, but I couldn't not do this one. So this is basically scientists that have proven that the 4 bases of our DNA, the G, C, A's, and T's that form the helix are not necessarily exclusive. So because if other chemicals can be used in other ways, then there's many other possible sources of life, right, elsewhere. So this is let's see. I pulled out a couple quotes here that I thought otherwise, so I could remember, but. So let's see. This says, so now scientists have doubled, I'm quoting here, have doubled the number of life's building blocks, creating for the first time a synthetic 8-letter genetic language that seems to store and transcribe information just like natural DNA. And they've been working on, there are scientists that have been working on this. And one of the scientists in this study, I think, said that his first successful initial demonstration was, a couple of decades ago. But here's a quote again. The latest study is the first to systematically demonstrate that the complementary unnatural bases recognize and bind to each other, and that the double helix that they form holds its structure. The team showed that synthetic DNA could be faithfully transcribed into RNA. The ability to store information is not very interesting for evolution, says Brenner. You have to be able to transfer that information into a molecule that does something. So they've gone quite a ways here. They're not done. The last quote I pulled out was that, quote, the work is an exciting starting point, but there is still a substantial distance to go before reaching a true 8-letter synthetic genetic system. One key question, for example, will be whether the synthetic DNA can be replicated by polymerases, the enzymes responsible for synthesizing DNA inside organisms. Not there yet all the way, but pretty darn close and pretty darn cool, I think.
Was this we've discovered 4 new things for DNA in our DNA that we didn't know before, or this is
Well, they're not in
a
our
completely
DNA.
different...
No. They're saying
Okay.
that this is synthetic. They're saying that they could create a form of DNA that includes
Up to 8.
up to 8 bases, and they're in 2 additional pairs. Right.
Right.
So, but very intriguing. Intriguing for what are we going to be able to do in another 10, 20, 50, 100 years?
I could grow a synthetic arm. Is that, if I really want a third arm, is that what this is?
No,
I'm trying to think of a useful application.
No. This is base science, my friend. This is not applied science.
Oh.
Although
Okay.
I guess I'm actually looking at this. This says he is the founder of the Foundation for Applied Molecular Evolution. So I guess they think it's applied in some ways, but yeah, no, I wouldn't think about that in these terms yet. I mean, if you want to go all wild, you would be so we'll be able to synthesize artificial forms of life, maybe, but I think we're a very, very long way from that kind of thing.
Huh. Well, cool.
All right. That's all.
Alrighty.
Better call it an episode.
Yeah. It's been a while.
All right.
All right. Have a good night, John.
I'll talk to you next week. Bye.
Bye.